Hi folks, and welcome back to Physics with Captain Rod. The purpose of this video is to show how to use the scalar formulation of torque to calculate the net torque about a point. So what we're going to do in this picture here, we're looking at this kind of beam-shaped or bar-shaped object here with all these forces here acting in the various directions. What we're going to do is calculate the net torque about point O. So remember that torque is force times distance. We usually use this letter, Greek letter tau. It's force times distance. However, the force and the distance have to make a right angle. Now there's two ways to accomplish that. You can either break the force into components and use the component that's perpendicular to the distance, or you can break the distance into components and use the distance component that's perpendicular to the force, either one. Remember that torque is a vector quantity. Generally speaking, clockwise or counterclockwise is good enough for a two-dimensional problem. And as a rule of thumb, counterclockwise is considered positive. Now again, you don't have to follow that rule, but I usually do. So, looking at this picture, if we're to calculate the net torque about O, there's 1, 2, 3, 4 forces that need to be considered. And I'm just going to work my way outward, taking them one at a time. So torque net about point O equals, all right, first we got this 50 Newton force 2 meters away. So you'll notice that the 50 newtons already makes a right angle to the 2 meters. So we're going to have 50 newtons times 2 meters. Now I'll evaluate the direction. This force makes this beam want to rotate clockwise about O, and I'm going to go ahead and stick to counterclockwise positive, so that torque term is negative. Alright, next force I run into, this 60 newtons. Now this 60 newtons, you'll notice its line of action goes right through O. So in other words, there's no torque or moment arm. So the torque produced by the 60 newtons is 0. I'll go ahead and put a 0 there as a placeholder for that force. Right? These two forces, let's take the 20 newtons first. Now the line of action for that 20 newtons is all along this line. The torque produced by the 20 newtons is going to be 20 newtons times the perpendicular distance to the line of action. So that's going to be this distance in green, which is the same as this distance. So I'm going to go over there and calculate that. So this distance, if you look at this triangle, the hypotenuse of this triangle is 3 meters, and that's a 30-degree angle. So that distance is 3 meters times the sine of 30 degrees. So I'm going to go ahead and put, 3 meters sine 30 degrees. Now I'll evaluate the plus and minus signs. This force makes this structure want to rotate counterclockwise about O, so that torque term is positive. Alright, next term. This guy, the 40 newtons. Now the 40 newtons acts all along this line. So the distance we need to calculate the torque, I'll do this in green, is that distance there. That's the distance we need that makes a right angle with the line of action of the force. So that distance, you'll notice it's 4 meters plus a little more, and the little more is adjacent to the 30 degrees, so that's going to be 3 meters times the cosine of 30 degrees. So that torque term is going to be 40 newtons. Oops, do this in black. And also, I need a little more room here. Go ahead and just move this equation over a little bit. Okay. Alright, so the next term is going to be 40 newtons, so that's this force, times this distance, which is going to be 2 meters, plus another 2 meters, plus 3 cosine 30. So I'm going to go ahead and just write that 4 meters plus 3 cosine 30 degrees. And I think what I'll do is write that again and put the units outside. Give me just a moment. So 4 meters plus 3 cosine 30, and I'll put the meters out there. Right now, plus and minus signs. This force makes this beam want to rotate clockwise about this point, so that torque term is negative. All right, equals. So what I'm going to do here is I'm just going to take a moment and pause this while I run a value for that. And back, folks, and I evaluated, and I got a numerical value here of minus 334 Newton meter, just force times distance. The minus sign means that the torque, 334 Newton meter, is clockwise. Either of these are acceptable answers. So again, the purpose of this video was how to calculate torque about a point using the scalar formulation of torque. Torque is force times distance. You just have to make sure that the force you use makes a right angle to the distance. So again, this force makes a right angle to this distance, no problem there. This force doesn't have a distance because its line of action goes right through O. This force, the distance you need is this distance, again, where it makes a right angle to the line of action. And for this force, the distance we need is this distance, again, where it makes a right angle to the line of action of that force. Another important thing to realize is the plus and minus signs. If we call counterclockwise positive, this force is producing clockwise torque, hence the minus sign. This force does not produce any torque about O. This force produces counterclockwise torque. I'm going to go back and make sure I said that right on this 50. This force produces clockwise torque, this one, and hence the minus sign. This guy does not produce any torque about O because it goes right through O. This force produces counterclockwise torque about O, and hence it produces positive torque. This force produces clockwise torque about O, and hence it produces negative torque. Each term needs to be force times distance. Units are Newton meters. The plus and minus sign will then tell you the net torque direction. So in this case, clockwise. Hope that helps demonstrate how to calculate torque. Have a great day.